Okay, sorry about the ending of the last video, but now it is time for me to tell you how to do this. It was because I was getting really confused because I didn't really know if I wanted to put that in a video, but that would make the video get way too long. So now I'm going to teach you how to approximate an alternating series. Now I wrote down another alternating series here, and does this look scary? Because there's a factorial. You're going to have to get used to that because the next unit in particular is going to have tons of factorials, and you're going to have to deal with them. So let's just clarify, remember that a factorial means they're multiplying all the numbers, the integers underneath it, so it'd be 3 times 2 times 1. That's what factorial is. For this reason, now we can actually use this in our functions right here. So what's going to happen is that the problem's going to tell you to approximate the sum of the series with an error less than or equal to 0.1 or 0.001 or 0.001, and basically it's going to tell you how specific it wants this to be. If you notice, we're constantly adding, well, okay, the first number is going to be 1 over 2 exclamation points would be 1/2. The next one is going to be some bigger number denominator. I think it's 2, which is going to be 4 exclamation points. So the next one's going to be 1 over 24. But, as you can see, the numbers are going to get, this is going to be, I think, 720, and it's going to keep getting, as you see, they're going to keep getting smaller, but they're going to keep alternating. So you can kind of picture it like this. It's getting bigger by 1/2, and then getting smaller by like 1/24, then getting bigger by 1, and it's going to keep jumping back and forth here. And so the idea is that this right here is going to be the value. Now, we would have to be doing it for hours and do like a million different steps to get the exact value, so I'm just going to teach you right now how to get within a certain area. So let's say, for example, that it wants you to get it between 0.01, which is the same thing as 1/100th. Well, think of it like this. If you had, let's add the 1/2, subtract the 1/24th, well, that means that, let's say that this is the actual value. By the way, this is supposed to be like a number line. I didn't really clarify that. This will be 1, this is 1/2. This is the real value. The maximum error right now that you could have, as in the most you could be off of the real answer by, is what the next one is, because the next one's going to jump right over it. But with all the knowledge you have right here, the most you can be off by is whatever your next one is, as in with your knowledge. And for that reason, you're going to keep writing out terms until you get something that is smaller than 1/100th. So we'll start off with 1/2, subtract 1/24th, add 1/720, and wait a minute, this is smaller than 1/100th, so we can stop. We need to use these two terms to approximate within 1 over 1/720 because this is the maximum error that we can have. But you don't want to include this because then you want to have something that's within it, and that's just going to be this. So this right here is two terms, and that means that this is equals, I believe, 11/24ths. Yeah, 11/24ths. The maximum error in this approximation is this. This is the max error. You can also write this as saying that the actual sum minus the sum of the first two, is less than or equal to 1 over 720. That's going to be the notation that they're going to use a lot of the time. So, to approximate what the sum of the series is, you're just going to say that this has to be in between that value, the 11 over 24, and that value plus the error. And that's how you approximate the value of an alternating series.